Guys, in this video I'm going to show you how to solve maximum distinct elements. So given an array of numbers and a number k, we need to remove k numbers from the array such that we are left with maximum distinct numbers. Alright, so for example, with this given input, which is an array of numbers, right, and we have a number k equal to 2, right? So our task is to remove k numbers from this array such that we're left with maximum distinct numbers, right? So what numbers we're gonna remove here? Because we want to maximize distinct numbers, so probably we're not gonna remove number that is already distinct, right? So for example, let's say for example 7 here appears once only, so it is a distinct number in this array, so we probably don't want to remove it. 3 appeared 3 times here, 5 appeared twice, 8 once, so 7 and 8 both appear once, right? And they contribute a total of 2 distinct numbers to the this final result. So we probably don't need to remove what number that appear once, right? Because it's distinct by itself. Alright, so probably here in this case, except from 7 and 8, wanna skip, we're left with 3 and 5 in this case. So probably a more clever choice here is to start with the ones that is appear less in the array, right? So that because we have a limited amount of removal, so we want to start from the one that appears less, so that we can have more removals in total. So it's kind of like a greedy approach here, right? In order to kind of maximize distinct numbers, right? So probably we want to start to remove from numbers appear twice upward, right? Mean from 2 times also upward. So this is probably a kind of task that is fit to a heap operations, right? Uh, we need an item, we need a number that is has the smallest value, right? This guy is occurrences. All right, what else we need to do here is to probably we need a loop here to um, remove uh, until we're out of k, right? So we don't need to remove numbers appear once. Okay, we remove number appear twice. So as you can see, these kind of things are in order to achieve these two tasks, we probably need to have access to the frequency of each number, right? So probably I need to build a frequency map with key is a number and the value is its frequency, right? Its count or frequency. All right. So I'm gonna start with a frequency is an uh, is an object here. It's an empty object because in JavaScript, uh, objects can be used like a map. Right? So for let num for each number from the nums, iterate, and for each number, check if it is not in the frequency map. In then gonna initialize it with value of 0, and after that gonna increment its frequency by 1, right? So at the end of this loop, we'll have frequency stores uh, all the numbers here with its frequency, with that frequency. So here is the logic of removal. We start to remove numbers appear twice. So here we need a heap, right? That allow us to get access to the number that is that has a list occurrences in the array. So I'm gonna define min heap here. Min heap new heap. All right, initially it's just empty, and the third argument will determine if it is a min heap or max heap, because this is a min heap, so it would be b minus a. So we need to decide here what do we want to uh, what do we want to store inside the heap, whether it is a number, its frequency, or both. Could be we could store with the number Each item is an array where the first item is the number itself, and the second item is the frequency, uh, number frequency. Right, here's my initial thought, but later I realized that we probably don't need to store the number here, right? And we just need to store the number frequency here, right? Because what we care here is the frequency that is has the smallest value, right? Then we're gonna use this number frequency. I'm gonna take out this number frequency out of the heap, right? We're gonna use that to subtract out of k uh, until we have until we have until k reaches 0, right? Our goal here is to count the distinct numbers, right? So it could be that so let's say, for example, let's say in heap we have a set of numbers which are the frequency of uh, let's say ABC, right? So let's say here are the frequencies of all the numbers from the input here, and assume that A will go out first because A is the smallest value here, right? So probably A will go out, and here is a frequency, and our goal here is not to remove our goal here is to remove what our goal here is to remove A minus 1 uh, I minus 1 element, right? Because when we remove A minus 1, then we're left with one occurrence uh, of the character that is mapped with this frequency, right? So when we are left with one occurrence, it means that we can uh, increase or increment the distinct numbers here, right? Without knowing the number itself, right? So that's the reason we're just gonna keep inside the min heap number frequency. All right. So probably we need to initialize our min heap with the frequency that is from 2 and above, right? We don't want to put the numbers that appears. We don't want to put the frequency that is 1 because it is distinct by itself. So I probably want to initialize our heap by looping through the frequency here. Let num of frequency, and if the frequency of num is greater than 1, then I want to put it in the min heap. Frequency of num. So with min heap, I will have access to the smallest frequency, right? That is at least 2, because here we don't add the frequency 1 to the min heap. So here we start to removing until we out of k, right? So as long as k is greater than 0 and um, probably the second condition here is min heap, we still have something in the min heap, right? So for each iterations, I'm gonna pop out one instance, which is the number frequency. So we're gonna oops for each number frequency we want to delete what number frequency -1 only, so that we are left with one occurrence of that number. But here we don't know whether the number frequency is smaller or larger than k, right? But we need to make sure that the maximum deletions we can make here is k, right? And to make sure when we delete these, we need to less than or equal to k, right? So the number of deletions here is going to compare number of frequencies -1 is less than or equal to k. If it's still within this constraint, it means that we can make this amount of deletions, number of frequency -1. But if it's greater than k, then we're just gonna delete this amount, which is k. Okay, deletions. All right. Okay. So number frequency. I'm gonna update it with by deleting this amount deletions. Also, I want to update the k as well. K subtract by this amount deletions. All right, as long as we have something Actually, if after the deletions number frequency is still is greater than 1, like it here, it means that we probably want to add back to the min heap dot add number frequency, right, for the next for later processing. All right, add it back here. If it's okay, let's double check it here. If we still have k and something in the mid heap, we take out one of the min heap, and it's a number frequency, the smallest number frequency in the min heap. So from this amount, we want to delete this amount, but we need to check it with k, because here is the maximum we can delete. If it's less than or equal, then we want to make this amount of deletions, else we can delete maximum k. So after that, I will update the number frequency with these deletions. Subtract this amount of deletion from the number frequency, and subtract these amount of deletions from the k. If the number here, if the number frequency is greater than or equal to no greater than 1, we could you could add it back to the min heap, right? And then what will return after all here is we want to distinct numbers, right? So probably right, we don't have anything to keep track of the distinct number here, so let's define a distinct nums. Initially is 0, right? So we want to, so distinct number can either the number that is has frequency of 1 initially, right, which is we can check inside here. If frequency is greater than 1, then at a minute, else it means it's equal to 1, right? Frequency of num equal to 1 here, then I'm a distinct number, increment it, and here we can update the distinct numbers after deletions here. So if the number frequency is greater than 1, else number frequency equal to 1, then distinct number is plus increment by 1 and finally return distinct number. Alright, let's run the test. Whoops. We have something wrong here. That's none of frequency. No, it is in frequency because we loop through each key in the objects. Num is a key, so we need in instead. Alright, we have one failing test. Let's see what it is. So, test number 2. Let's say this array make 3 deletions. Let's run it manually here. Alright, our map will be 3 appear once, 5 appear once, 12 appear twice, and 11 appear once. So the thing that is on in the heap is will be only this one, this record, and when because these are this thing by itself, and I'm gonna push the frequency of 12 inside here. So k here is 3, right? It means we have to make 3 deletions, right? I know why, because here inside here for the first iteration here we take out 2, right? And we want to delete one occurrence only, so that we have left with 1 distinct elements. Using num initially is 3, right? So we take 2 out. We want to delete this 1 occurrence, so we are left with 1. And we'll, after deleting, we increment the distinct number by 1 here, right? But now our heap is empty, so we'll exit this loop. But because we only make 1 deletion here, sorry, 3 minus 1 is 2, so we left with 2 more deletions. So here k can be still greater than 0, and if k is still greater than 0, I need to delete even it is a distinct numbers, right? So it will be distinct numbers minus k, or if it's equal to 0 here, then it will be the distinct number. Alright. Alright. So I think that is it for this problem, and thanks for watching. See you in the next video.